In this lecture, we will implement a cool ability that, in my opinion, we all would like to have in real life: remote object pooling. We will start with a grab component, and we will follow the approach similar to what we currently have for the grabbing. So first, let's create a variable called b is pulled. That will be set to true or to false at the moment we try to pull the object or we drop it. And we need a function called try_pull. In this function, we will iterate over all the grab components our owner has, and we will check whether any of them is currently being pulled. If yes, we will return false. If no, we will set is pulled to true for our current grab component and will return true. So here we get is pulled. And then we use the branch to check. And so if it is true, it means that we are already pulling the object. Let's create the output here. So in this case, we will return false. No need to pull again. If you wish, you can extend this flow control with the isHeld variable, but we will just leave it like this for now. And in case we have iterated over all of them and none of them is pulled, including us, we will set isPull to true and we'll disable the physics for the object because, for example, we don't want the gravity to interfere when we are pulling something. And we will return true. And now let's go to try_release function, and we're gonna need this code over here. It manages the moment when we drop the object and we can turn on the simulation of the physics or not turn it on. So we will convert this code to a function. Because we want to reuse this function, right now it's used only for the moment we release the object from the grab, but we will also use the same logic for the moment we release the object from the remote pulling. So you try to pull it, you stop pulling it, it falls to the ground. If it even can, in theory, fall for the ground. So we will still leave this choice for the grab component itself to decide whether to do it or not. Let's adjust this, and we're gonna need one more function that is called stop_pull. So this is pretty simple. We will just call this function to set the is pulled true false. First, I will check whether it's true in the first place, and then let's set it to false. And now our object can be held because that's the final destination of our pulling. So whether we do not hold the object, we will try simulate on drop using the function we have just created. Now let's go to the try_grab function, and inside try_grab function, because like we are pulling the object and we want to grab it in the end. So if the grab happens, we have to interrupt the pulling. So over here, when the potential grab happened or not, we check whether it was successful, and if it was, we will stop the pull. All right, now one interesting thing. There is an ability for us in Unreal Engine to create functions that we will be able to reuse by any other blueprint, so they will be globally accessible. For that purpose, we have to create a specific blueprint that is called Blueprint Function Library. Let's call it VR Function Library, where we're gonna place our global functions. And we need one function there that will return the top priority grab component from the object. So this will simplify our life a lot for the cases when we, for example, are pulling the pistol. Pistol has two grab components, and for us it might be beneficial just to attach it finally with the top priority grab component. So with exactly that hand that can trigger the shooting. Otherwise, we will have to switch hands and it may not be that comfortable. So let's here create the input actor. So this is the potential actor on which we will try to find grab components especially the top priority grab component. Here we add the grab component filter. Let's first check whether it has elements, because if it does not have any elements, it makes no sense to do all that logic we will add here. And yeah, so we add the branch. Now we're gonna need a local variable. We're gonna call it the out grab component, and initially it will equal to nothing. It's gonna be empty, but we will update it in case we will find any grab components, and we will update it every time we will find the grab components with higher prio. For this purpose, one more local variable called top prio that we will use to keep track of the current maximum priority we have seen so far. And of course, the output variable, the grab component we should return. So it can be null. Just remember this. Because who knows, maybe we just try to pull the floor and the floor does not have any grab components. So we should just return empty variable here. So if we got to this point, it means that we have at least one grab component inside our array. So we will initialize our local variable for the output with this grab components. So it means we will definitely return at least this grab component. And now we're gonna do just a simple for loop, an iteration. And here we will get the priority of the currently iterated grab component. And we will check whether this priority is higher than our local variable top priority. And if it's true, we will update technically both variables. Top priority we will update with the priority of the current element, and then we will update our out grab component variable again with the current element. So it means that we have found the grab component with higher priority, and now we should return him, not the one we set at the index 0. And on completion we will return the grab component we have found. We should also do this over here. Here we will just return the empty variable. Let's compile and save. Cool, now we have this very useful function. Now it's time for vrpawn. In vrpawn, first what we're gonna do, we will have to create two more variables. Right now, for the grabbing, we keep track of the grab components we currently grabbing, but we will create two more for tracking the grab components we are pulling at the moment. Let's just quickly create both of them. Cool. Now we're gonna need two functions. The first one gonna be called trace aim, and will perform exactly the tracing forward to get the object. And in analogy with the function that returns the grab component near the motion controller, we will return the one not under motion controller but under aim. Probably we can call it like that. Let's start with implementing our trace aim function. So as it usually happens, we can use different options here. First, let's create an input variable where we will pass our motion controller, and technically we could use some sort of line trace here or maybe something else, but line trace is pretty thin, it's very easy to miss the object, so we're gonna be using sphere trace. To use sphere trace, we'll get the world location and forward vector from our controller. This will work because it's gonna represent the aim of the controller. So let's create our sphere trace by channel over here. The world location will be the start of the trace, and let's connect them. And then we're gonna add the forward vector, but the forward vector will be multiplied by the length of the trace. And here you can select the value that fits for your project. Maybe you don't want to allow to pull objects that are fully remote. We can use something like 10,000 to cover everything for 100%. Now let's multiply, and this will be the end of the trace. So this is the base blueprint for our sphere trace. and we're gonna have to return something from this function. So let's return two things exactly in analogy with what this trace returns. So first one gonna be the Boolean variable, whether it hits, and then the hit result that contains all the result about the object we hit. And now let's connect the outputs for the trace right to the output of our function. Here, let's select the for duration and select 5 because we do not draw any visuals for the trace, and it will help us to identify where we are aiming to. Now, let's implement our getGrab component under aim function. That's the place where we'll perform our trace, and we're gonna have to add the input variables, for example, the motion controller that we then gonna pass to the trace aim by object reference. Let's connect the motion controller, and here we're gonna just check whether we hit something with a simple branch, and if yes, we will try to get the actor from hit result. So this is our potential Boolean target, and we can use find top prio grab component function, the one we implemented at the beginning, to get the best potential grab component that we're gonna be pulling after calling this function. And we will return it over here. Of course, we're gonna have to handle the case when we hit nothing and just return the empty variable. We can minimize this as the only thing we need is an actor. And now let's go to the event graph. And let's find the try grab event handling. Yeah, so here it is. And what we're gonna do, we're gonna take all this code and convert it to a function. And let's just rename it try grab left. All right, so here it is. And let's do the same for the right hand. And why are we doing this is because at the end of the pull, we might want to initiate this grab. So it's comfortable for us to have the function, so we will not copy all this graph every time. Let's name it try grab right. And we can rename the input variable for each of them. Now we're gonna have to handle our pulling in the same place we handle the grab. So let's get us some space by moving all of this a bit down. And we will start with the right hand. So we also move this. And here, so how it gonna work? First, we initiate the grab near. If we haven't found anything, we will try to find something remotely. So we will call this function we have implemented, getGrab component under aim. But here, important moment, we will not pass the left motion controller. We will pass the motion controller aim. The motion source it uses give us exactly the location and forward vector that we're using for the trace that represents the aiming of the controller. So technically it's kind of similar to what we've been using for the menu to identify which widget we are pointing to, but this time we're gonna do this just manually and we'll use it for the trace. Here we will check whether we have found the grab component remotely. So for the user, for the player, this should be still some valuable object to grab. We will just initiate pulling for it before grabbing. And we will try pull here. In case we have successfully pulled the object, we're gonna save the reference to our pulled component to one of the variables we have created in the first place. Later, we're gonna use this cached variable to exactly update the pulled object, to update its transform, and in the end, try to grab it. And this code on complete here, we will have to handle the dropping of the object, because we can kind of drop it in the middle while it's not yet in our hand, but we have changed our mind and decided to drop it. So we're still gonna have to handle this case, both for pulling and for grabbing. And we will get the reference to our pulled component, check if it's valid, and if it is, we will call stop pull for it. Which, if you remember, might initiate the physics simulation, so it will just fall to the ground. And we will have to clear our reference to the pulled component, so it won't be updated any further. Now we're just gonna have to do the same for the other hand. Let's move all this time. And exactly in the same way, but for the other hand. Probably we can just copy all of this here for simplicity and just connect it in the right way. Just don't forget to use the variables for the right hand, which means for the left hand in our case. We'll need to set the left pulled component reference over here. And as last time, we will handle the dropping of the pulled object here. So we take our left pulled component, we check if it's valid, and if it is, again, calling the stop pull function. And we'll have to clear the reference to this component. And we are getting closer to the main part where we will actually update the pulled objects, their transform, so this will simulate how they fly to us. For this, we'll have to override the tick function. You will have to make sure that it's turned on in class default, start with tick enabled, should be set to true. And for simplicity, we'll create a separate function for updating the pulled object. Here we're gonna have to add a few variables. First gonna be the delta time. It will help us to update the location of the pulled object. Then the pulled grab component, we're gonna use it exactly to get the object we are trying to pull. Let's set the correct type, grab component, and the target motion controller. So that's the motion controller that represents the hand to where we are pulling this object. So for example, right hand motion controller also requires the correct type being set over here. First, we're gonna check whether the pulled component is valid. And if it is, we're gonna have to get the owner from this pulled component, because we're gonna apply the transfer change for the owner. It, for example, gonna be our pistol or our cube. We're gonna get its current location. And from our hand motion controller, we're gonna also get the word location. This is gonna be the target location where we want to pull that actor to. Now we can use the function called vinterp2constant. What it does, it simply a little bit shifts the first variable to the second and uses the delta time to kind of do it smoothly. So every frame we will be shifting the location of the object a little bit towards the desired location, which is the location of our hand motion controller. So we pass the shifted location and select the teleport so the physics won't interfere during this move. And in the end, we're gonna get the current location of the object after the move. And what we're gonna do, we will compare how far we are still from our final destination with some threshold. And if we are closer than this threshold, here we'll return the Boolean variable that will indicate whether we can try grabbing the object, because that's our final goal, right? We are pulling the object, so to grab it in the end. And here we will do this comparison. We will have to return false here, which means that the pulled component is non-existent at the moment. So here we will have to do a sequence for left and right hand where we're gonna call this function. Here we're gonna need branches. And for the case we can try grabbing, we're gonna call the correct function. And here try grab right. Now let's pass the correct variables. Here gonna be the pulled component left. We also gonna need to connect it over here. And the motion controller left. That represents our hand exactly. It's not the aim, but just the left motion controller. And the right pulled component for the right hand, and the motion controller right again for the right hand. And we need to connect our pulled component to the try grab function. And now, after trying to grab the object, we're gonna have to add a return to this function, which will indicate whether we have successfully grabbed the object or not, just for comfortability. Here we will return true. And for this flow, we also gonna have to return true. Now let's do the same for the other hand. As you can see in this function, we have the output already. So again, just the Boolean variable. And the positive return over here. So here we're gonna need two branches for the left and for the right hand. And for the case when the object was successfully grabbed during the pull, we will have to now clear the pulled grab component reference. So we won't longer update it on tick. And for the other hand. All right, so we also gonna have to connect the delta time. Let's not forget to do that, otherwise it won't work. And here I have forgotten to specify the trace radius. You can try different values to see which one works best for you. In this function also, this should be true, yeah. On my end, I also had this disconnected in Basic Animation Blueprint. You should not have this error, but please just make sure you have it connected. Now put your headset on and let's test. So when I press the grab, you can see that the sphere trace is happening. I can throw and grab objects on the fly. I still can shoot from the guns. and it works for any kind of object, while for the gun, you see, we are grabbing it by the top preview component, and our two-handed grab still works. So it's done.